righty. Can everyone hear me okay? Let's see. Are you guys able to hear me? I'm not sure. Oh, here we go. Perfect. Thank you. I can see that message there. So this is my name is Paul. This is my first time doing the webinar here. So bear with me with all this go-to meeting stuff. But let me see. So we've got it recording, and it looks like you guys can hear me okay. So yeah, I think we're good to go. So what I'm going to show today is going to be BobCAM for SolidWorks V9, and I'm using SolidWorks 2022 in here. And I'm just going to kind of walk through kind of an example part, so that way you guys can kind of get a sense of the workflow for milling. It's going to have some 2-axis and some 3-axis stuff in there. So let's go ahead and get started. Can you guys see my screen? I think you can, but I just want to double check to make sure. Maybe. Don't see anyone saying. Let's see. Can somebody maybe send me like a message in the questions, just to make sure that you guys can see everything and you hear me okay? I see that there looks like there's 11 people in here right now. Okay, perfect. I appreciate that, Warren. All right. So yeah, let's go ahead and get started. So what I'm going to do is I'm just going to import a part here. So let me just go ahead and do that really quick here. And so this is just a step file that I'm importing. The actual part itself, I just grabbed it from GrabCAD, but basically what it is, I'm a big golfer, so this is actually a putter head. So this is, and I kind of, this is kind of a pretty great example for milling here. So yeah, we'll kind of walk through this one. So let's go ahead and get started here. So this one, it doesn't have the hosel or anything, it's just the head. And so what we'll go ahead and do here is just basically have 2 different machine setups, one for each side. So let's go ahead and start our job here. And so one thing that I like to do personally is I don't normally mess around with using any of the options up here. I mean, you can, but I like to do almost everything inside of the CAM tree. So the way that you do that is you just right click on stuff in the CAM tree. So yeah, you'll have all these icons, but just to make it more simple, I'm just going to be right clicking on stuff today. So what we can do to get started here is we just right click on CAM defaults and hit new job. And then we're going to stick with milling, and I'm going to stick with just the default machine here, and we'll hit the check mark. Next, we load this page, and this is the workpiece page. So if you have the 3D model, which we do in our case, we'll select that. So I'm going to select it from the drop-down list here. And this is just used for simulation purposes. So that way you can compare the model with the stock and simulation. And you can see you can use the deviation, or you can use the gouge and excess just to double check to see if there's any gouging anywhere or any leftover material. And the deviation is good because it gives you different colors depending on how much material is left over or not. So that's really where this workpiece is going to come in handy. But otherwise, you don't have to have one here. You can leave it blank. It's just not going to pick up anything in the simulation for that. So we're just going to hit next here. And then on this page, this is the stock stock page. So this is just defining the stock. Now in our case, you can kind of see that it's kind of not fit like the way that we want to. It's kind of like the box is here and we kind of want it to be aligned with our actual part. So to do that, you're going to scroll down to the bottom here, and this section right here, the stock orientation section, that's what we're going to use to align the stock. So we're down here, so let's go ahead and do that here. Now, one thing I noticed is to get this to actually show up, so if I click in here right now, it's not active, it won't let me click on it. So the reason why is because right now we have it set to bounding box, but we actually want to set it to enter because we're going to enter in our own stock here. And then as you can see, it actually highlights it now, and now we're able to pick our origin and stuff like that. One note on this page that I want to bring up is we are not defining the CAM origin right now. All we're doing, the gnomon that you see here is just for utilization purposes for the stock to align the stock correctly. So you don't have to worry about defining your machine origin location and all the axes and stuff like that yet. We'll do that in the next step. So in this step, though, we are going to utilize that to get everything aligned. So what I'm going to do is in the pick origin, I'm going to pick, for instance, let's pick this point right here. And so that's just setting the origin location. And I just want to set it somewhere on our part just so we have a reference. And then from here, we're going to use the X, Y, and Z directions to actually align the stock. So when I click on the X direction box here, it's going to highlight to make it the active selection. And then all I need to do is select a line that's parallel. So I don't have to select a line that's coming straight off of the origin point. I can select like up here. And then as you can see, now this X is going to be parallel to that line, which is what I want. Now, I think that's the only thing I had to change in this one. So let's go ahead and just recalculate this stock here. So if I just go back to the bounding box, it should fit back into the correct orientation as you see here. And now this is exactly what I was looking for. So we're good with the orientation of the stock now. So this part is done. So now what we want to do is we want to set up the actual dimensions of the stock. So to do that, you could hit enter and select them here if you know the exact numbers. In my case, I'm just going to add a little bit of material to each of the sides here using these offsets down here. So if I go ahead and enter, let's just say an 1/8 inch here, you can see how it adds an 1/8 inch on the side here. And we'll just continue to do that all the way down. So 1/8 inch, 1/8 inch. And then this last one, I'm going to actually make this one a 1/4 inch, just so I have some extra material at the bottom to hold the piece. So I'm going to do a 1/4 inch on that one. And then we're going to go ahead and hit next. So now what we're going to do is we're going to go ahead and define our machine origin. So this is the important bit. This is what the actual post is going to look at when it's actually creating the X, Y, and Z moves. So we need to make sure that this is set up correctly in here and then set it up in the same location on the machine. So what I'm going to do in this case is it's already defaulted to pick origin, so that's what I want. So I'm going to select the top corner here. And then we just need to realign our coordinate system. So I want the X running down here. So same thing as we saw in the stock, we're going to do it here. So I click inside X-axis and click that line to have it run down. And then I want the Z to face upward. So you can just hit this little reverse icon. And then as you notice, it actually moved the X back, and that's just because of the right hand rule, because it's using a combination of 2 different axes to find the 3rd axis. So really you just have to use these reverse directions until you get it into the orientation you want. So I think actually what I want to do is use Y axis to invert that. That way I have the X axis defined here and then the Y this way, and then it forces the Z face upward. So if you ever notice that, just keep playing around with the reverse buttons until you get it to the orientation you want. And then one final step down here. So as you can see, you can define the work offset number. So that's going to be G54 for 1, G55 for 2, and so on. So we'll leave that set to 1. And then down here, so I'm actually going to set this Z here. So I can't remember the exact length of my stock here, but I'm just going to set this to 1. The reason for this is because in simulation, if I have these all set to 0, but I have my my coordinate system set to the top, it's actually going to put all of the stock inside of the actual machine on the table, because that's just the way that it references the stock in simulation. So by putting this to a 1, it's just going to basically move it up out of the virtual machine in simulation. So that's what I'm going to do. Actually, there's one other thing I wanted to do as well. So I actually want to move my coordinate system down, so that way it's set to the face of this part. And really the reason I want to do that is just to make it easier to understand the actual numbers while you're actually programming, and also while you're looking at the G code. So that way we have a good reference for where the actual top is, because I'm just going to face off the top here. So if I hit enter, one thing you want to note here when I'm actually adjusting these is it's actually referencing the CAD origin, the CAD. So down here you can see the actual CAD coordinates. So as you can see, the X is facing downward, and I want to move this down here by, I think it was, we set it to 1/8 inch. So we're just going to add 1/8 inch right here. And then you can see how it shifts our CAM coordinate system down. Let's see, actually, I think there's a question. Can I translate origin by dimensions in Z? Yes, I think you're talking about exactly what we're seeing here. Is this what you mean, how we're shifting it? So if you hit enter origin, this is what will actually shift it one way or the other. So hopefully that answers your question. But yeah, so now we have this set here, and then we're just going to hit the check mark. And so that's the basic kind of setting up of our job. So now we have our list here. We have our stock created. We have our workpiece selected. If we click on machine setup, that's going to actually show visually where our CAM origin is. So if you ever get confused or lost or where that's actually located, just click directly on machine setup and it's going to show up for you. So now I've got all that set up. So now we just need to start putting some toolpath on this. So what I'm going to do first is I'm going to go ahead and do that facing feature. So and again, I right click on everything in the CAM tree. So I'm going to right click on machine setup, and it's going to show me my list of all the different features that I can select. So if I click on machine face or mill facing, that's what I want. And then from here, we have this dialog that pops up. And I can't remember when we got this this mill facing feature. I think it was maybe V31 or so. Before you would just go under mill 2-axis, and then there would be a mill facing in there, and that one is still in there. But the mill facing feature, it has a couple more things to it. So it pulls up this box, and it basically says that it can basically use the stock to try to figure out how big it needs to be and so on. And so you can still select geometry like you can see here, but I'm actually going to just let the system do it for us. So if I just hit next, and now you can see we're on this page. One thing I just noticed here, my decimals are set to 2. I'm going to change that really quick, actually. So just going down to here, edit documents. And then I'm going to set this to 4 places, and we'll hit OK. Okay, so let me go back to that page now. There we go. So now I can see everything. Just so you know, if it is set to 2 and I type in like 1, 2, 5, it's still going to be 125 in the background. You're just going to see it say, 0.13 or 0.12, whatever it said there. But yeah, so I just want to see all my decimal places. So as you can see, it's already set up. So it already has our top of feature is set to an 1/8 inch, because remember we set our machine origin down an 1/8 inch. So that makes sense. And then we're going to a depth of an 1/8 inch, which also makes sense because that's where our face is. So as you can see, it's already done everything we want. So we'll hit next. And then facing, only option, pretty easy. And then one thing on the posting I just want to bring up real quick is that you'll always have the option to change this work offset number whenever you want, and it's going to be per feature. So if you set it up to something different and you just need to change it really quick, you can just come to this page and set it to whatever number you need to set it to, and then it'll post out with that work offset number. So just keep that in mind. And then yeah, so now we're just going to go through this and set up our tool and stuff like that. So I think with this one, I'll go ahead and just use an inch diameter here. And I'm not going to worry about all this other stuff for now. We're going to leave most of this stuff default for this training. So yeah, we're just going to go to the next page here. And on this page, you can see you have a bunch of different pattern options. You can do adaptive if you want to machine away bigger chunks of material at a time, or I'm just going to keep ours on zigzag for now, but you have the different pattern options here. And that's basically it for this page. Also, your step over is here. So this is just the percentage of your tool diameter. So we'll leave that set to default. This parameters page is just setting up, like if you want multiple passes down. So yeah, let's just go ahead and I'll just put 2 passes on here so you can see what it'll look like. And you can set up the depth of cut there, and then it'll automatically show how many number of cuts that's going to be. And then on this page, nothing too much here to change. It's just kind of controlling the lead in and lead out, and there's not much that we really need to do on that. The link is just the links in between the passes, so you can do an arc or a just straight line over. I'm just going to leave it on the direct here. And then nothing much here, so let's just hit compute. And so now you can see there's our toolpath, and also notice how it already automatically extended the toolpath off of the part, so that way the tool comes all the way off the part. So that was under, again, mill facing, so there's just a couple of extra things you can do with that one. So I would recommend using that one when you can. So now we're done with that, so I'm just going to hit this little arrow to close it up. And then in 34, yeah. And also V9, you have these buttons on the side here to toggle, which I love because it's super fast to do that. So just going to blank out the toolpath for now, and we'll just move on to the next feature. So what I'm going to do next is we'll go ahead and do a 3-axis feature here. So again, you right-click on Machine Setup, go to Mill 3-axis. And now we're going to go through our little dialog for the 3-axis. So select geometry. You can do select whole bodies and just pick the body. You can also go through the list again and select it from there if you want to. And then we'll hit the check mark. We're not going to worry about a boundary in this case. I'm going to be using the Pro Toolpaths. And so it's already going to understand the stock and create toolpath as such. And in this case, it's just open area. So we want to start from the outside and work our way in. And so we don't need a boundary. If we set a boundary up, it'll try to stay inside of that. And so you don't want to do that in this case. So we'll just leave no boundary for now and hit next. All right, and then now we've got the same kind of page we saw before. The feed, rapid plane, clearance plane is all in reference to this top of feature. So keep that in mind. Whenever you set up the top of feature, it's going to reference, these are going to reference that. So this would actually be, 0.1 up from the top. And now in our case here, what we actually want to do is set the top to 0 now because we've just faced off all that material and we don't need to, add toolpath to that again. So if you just set that to 0, that'll give us what we want. And then we'll hit next here. And now we're setting up our strategies. So we've got a couple of different strategies we can do with this. I'm going to stick with some of the basics for now. So we'll do an advanced rough. And this advanced rough is going to be part of 3-axis Pro. If you were using 3-axis standard, you would use Z-level rough. I just want to say a note on this is for all the guys that have Pro, try to use the advanced ones instead of these. These will still show up for you, and you can use them for the most part, but the advanced options, the advanced ones will have more options for you, and it'll just be better all around. So instead of using Z-level rough, use advanced rough. Instead of Z-level finish, use advanced Z-level finish. And instead of planar, use advanced planar. So in our case, we'll use Z-level rough, and then I need a feature to get our walls. So advanced Z-level finish is a good one for that. And then we'll also add in a flatlands. Most of my floors are flat, so I think actually all of them are. So we'll go ahead and use flatlands for that because flatlands will only get the areas that are flat. If it's even deviated up by a little bit, it won't machine that area. And this is what I want for this part. So I'm going to stick with the flatlands as my other finishing. Now on this page, again, you have this where you can set up the work offset number. I'll leave that. You can check off arc fit if you want to post out arcs in the post. And then it's just a matter of setting up our 3 operations here. So what I'm going to do with this one, I think I want to use, I think it's a 3/8 is what I was using before. Yeah, let's use a 3/8 tool here. Again, I'm not going to mess with any of this for now. And then we're just going to go through here with the patterns. I'm going to leave it default to the offset out. But if you ever want to do like high-speed machining, stuff like that, you would use adaptive roughing. So let's leave it set to offset out. And then this one here. So this is just setting up your default, your depth of cuts. So what's that distance between the depth of cuts? What's that distance between the step over? Then you also can set up your allowance here. You can do side, you can have 2 different allowances, one for the bottom, one for the side, or you can just leave it set to global. So I'm going to leave this set to global for now because we're going to have our finishing passes clean up all the material in the floors and on the walls. And then one thing I want to do here is I actually want to set up a bottom of job. So what I'm going to do is I'm going to select bottom of job, hit pick, and we can just hit no on this. So I'm going to select an edge on the bottom here. Now, this is a putter, and so the face of the putter actually has a slight angle to it. So this would be like the actual position of the putter sitting up. And so this face actually usually has like a 4-degree angle or so. So what we want to do with that is just keep that in mind because if I selected this edge, then obviously that would be a little bit higher than this edge. So I'm going to select this edge and hit OK because that's the edge that's further down. And we're going to get this number. Now, if I remember right, I think I need to go down a little bit further on this one. So I'm actually just going to turn this into 1.25. And then I'm actually going to use this for our finish as well. So I'm just going to copy that right now. And we'll paste that over when we get to the finish page. And then on this page, it's the leads page. So really the only thing you have the option to ramp and so on. So you can do spiral, zigzag, all that good stuff. But that's really for the center cutting tools. In our case, we don't care about any of that. We're going to start from the outside and work our way in. And so I'm just going to uncheck the center cutting tool button because we don't need to worry about any of that at all. And then we'll hit next. Not too much to change on this page, except the machine flatlands is good to use when you have different floor levels, because if you think about it, if we don't do anything and we set that depth of cut, and it's always going to be the same depth of cut, and it's not going to know to do an extra pass to clean up the floors in certain areas. So when I hit machine flatlands, what it does is it adds an extra pass on the floors, and it's going to still stay within our 15 thou allowance, but it's going to add that additional pass to clean up all the floors down to whatever allowance we set here. So and this is a good case of that because we do have like 3 different floor levels here. So that's why I'm going to turn this on to add that pass, so that way we're not trying to machine a lot of material with one of our finished passes. This page is just the way it controls the linking between the moves. I'm just going to leave that on direct for now. Gouge check. I don't typically use gouge check for the most part for the 3-axis pro stuff, just because of the way I select the geometry. So typically I select the whole model no matter what for my geometry. And if I ever need to adjust, if I ever need to constrain the toolpath, I just use the boundary or the top and bottom of job. So really, I almost never need to use this. I mean, sometimes it's useful, but for the most part, if you do it that way, you don't need to worry about it. So I'm not going to do anything on this page. We'll hit next. And then this is just the advanced feed rates page. So because I'm using advanced rough and not the Z-level rough, I have an adaptive feed rates option just to try to control the feed rates. I'm just going to leave it on standard for now. And then on this page, so now we're going to our first finishing operation here. I think I was using an 1/8" ball here. So we'll just set it to an 1/8" ball. And then we'll just go through this one. So, one thing that's kind of good on this page is you could do a spiral for your toolpath, so you don't have to worry about any linking moves in between that could scuff the part up or whatnot. But for this one, we don't need to worry about any of that. We're just going to stick with zig, hit next. And then this parameters page, similar to the other one, we're setting up our depth of cut here. So I'm just going to set this to a 20 thou so we can get a nice finish on the walls. You can also do, these buttons are really useful, and this is also something that's not in the Pro, but the adaptive depth of cut, it'll add additional passes when you get to shallower surfaces. So basically, as it flattens out, with this toolpath, it's really good for floor or walls. And so as the geometry gets flatter, there won't be as much toolpath because it's just cutting at Z levels. And so adding adaptive depth of cut will add in those additional passes to try to make it a little bit smoother. So let's go ahead and just enable it for now. And then again, we have this bottom of job, which we're going to set from the other one, which was the negative 1.25 from the top. And then no allowance on here. We're going to leave that default and hit next. On this page, you can set up lead-ins and the way you enter the part and all that stuff. We don't need to worry about this page in our case, but these are options you have if you ever need that. Typically, I don't need to change much on this page for my Z-level finish, so we'll just hit next on that. And then on this page, there's a couple of cool little features on this page. The cutting extents, I think the cutting extents and the boundary options are important to know, like why they're used, because they do play a role in the way that it generates the toolpath. So for instance, cutting extents, and this applies definitely more for the finishing passes, it's the way that it processes the edges. So if I just leave it on extents, it's just going to be the center of the tool is going to go out to the edge. So you would get extra material down here and it wouldn't machine all the way. Um, so, that just keep that in mind because that's the default one. So if you do have more curvature and stuff like that, that may come into play. It may not, it may, but it just depends on your actual geometry. So typically I use the other two. So you have part bottom, which just makes toolpath all the way down to the bottom of the part. Of course, though, it will look at this bottom of job, so it'll go down all the way to where you set this one. And then the 3D extents, it just moves the tool out past the edge to try to machine the entire surface without going all the way down. So those are usually the two that I tend to use. In our case, we're just going to set this to part bottom because I'm just going to have it come all the way down with where the roughing ended. And the boundary options are important if you have a boundary because it creates the toolpath to constrain it inside of the boundary. So if I have it set to center of tool, the center of the tool will come all the way out to the edge of the boundary. So I think some people don't really understand that, but it comes all the way out to the edge. And so your tool would be outside of the boundary technically, like the half of it would. So if you want it to stay completely inside, you would just use tool inside. Or for whatever reason, if you wanted it to machine the outside as well, you would just do outside. And then notice how you have an offset as well, that you can adjust the offset in a little bit if you need to. So in our case, we don't even have a boundary, so we don't have to worry about it here, but just keep that in mind. So I'm just going to leave it set to part bottom. Rest finishing, that's a whole nother thing for another subject there. So we'll just leave that at that for now and hit next. And then this is, again, just the links. So I'm just going to leave this default, but you have a bunch of different options for the linking. Again, I'm not going to touch the gouge check. I'm not going to worry about this page. And then we're just going to go straight to our flatlands now. And the flatlands, I'm going to just use an 1/8 inch flat. So that way I can get all of my corners, because I have some corners here that I think they're like 0.1 something for the radius. I can't remember the exact number, but I just need a tool small enough to be able to get into those corners. So I'm using that. And then on this page, again, this is different patterns. So adaptive roughing be more for like the high-speed machining. So we'll leave this set to offset, and we'll just hit next. Setting the step over. So let's just make this 50 thou. I think that's basically all I need to do on this page. So let's leave this default for now. There's one thing about that, but I'll show you that in a second. Again, the entry and lead in, we'll leave all that default. Again, the boundary options, we have no boundaries, so we're not worried about that. Linking, not worried about that. Gouge check, advanced feed rates. So I'll leave all this default, and we will hit compute. And then we'll see what we get. All right. So there's our toolpath. I'm going to blank out the feature, and we'll just look at this one at a time. So the roughing, just a general roughing strategy, and you'll kind of see if we do a backplot. So right-clicking on the operation and hitting backplot, we can see it right here without going to simulation. And you can kind of see, as I was saying, it starts from the outside, works its way in, and so on. So we'll go through the simulation here in a sec. The next one was the Z-level finish. So there's our finish. We got really clean toolpath on the side. As you can see, when we get down to this more shallow curve here, we get less toolpath, which that's fine. I'm going to do a different toolpath to clean that up later. And then the flatlands, as you can see, it just finds all the flat areas and creates toolpath. So this one's a really good one if you guys have never used that one before. So that's going to be our general features. Now there's a couple more things I want to do though. So one is going to be, I actually want to clean this up a little bit more because I already know that there's going to be extra material there. And also I just want a really clean pass along this curve here. And so if you measure this curve, I think it was 3.32 or 3125. Yeah, so 0.3125. So what I'm going to do is I'm just going to do like a two-axis feature with this. And I'm just going to use um, a tool to just run straight across that and just clean that up really, really nicely. So what I want to do first is I want to create geometry for that because I could get away with trying to do this piece and this piece, but it's a lot cleaner to just have one toolpath go all the way across in one go instead of trying to break it up and then it would do this one first, wrap it up, etc. I just want it to come straight across the part. So I need some geometry to reflect that. So what I'm going to do is I'm actually going to go enter into a sketch. Now I'm going to actually enter into a 3D sketch to make it really easy for me to just grab the 2 points. So I'm going to hit line and I'm just going to select this point and drag it all the way over to this point. Just like that. I hit escape on my keyboard to cancel that out. And so now I've got a nice line that I can use for my geometry selection here. So I'm just going to exit my sketch now. And now we're going to go ahead and create our toolpath. So if we right click on machine setup, I'm going to go to mill two axis, select geometry, and we're just going to click on that line. Also, alternatively, you can select the sketch here too, especially if you have like a whole chain of multiple entities. That would be useful. In our case, we can just click on the line, and then we'll just hit the check mark. And now we just go through here. And so this is the two-axis mill wizard. So we'll see that we have feed, rapid, clearance plane, just like we saw in all the other ones. Our top of feature. So in here, we actually want to change this because it's not going to be 0. It's not going to be up here. It's going to be here. So I'm going to hit pick top. And we can just say no on that. Just click the line. And then now you can see we've set our top. And then our depth of cut, we can do pick bottom. And I'm just going to select this bottom edge. And then we hit next. And so that way we've got that set up and we're not going to be coming all the way up to the top or whatnot. And then we hit next. And in our case, we're just going to take one profile pass across. So I'm just going to use a profile finish. Don't have to worry about tabs. That's for something else. And then in here, I'm just going to use that exact same diameter. So it was 3125 times 2 because that was the radius. And then 3125. So I'm just going to use that tool. System compensation comes into play here. So it's basically just what side of the geometry you want to machine on. What I like to do is I'll just leave it default for now, and we can come back and change this after it's computed if it's on the wrong side. So I'm just going to leave that. We're not worried about any allowances or anything like that, or even any multiple passes. We've already cleaned up most of the material. We're just doing one final pass here. So leave all this default. The leads page again. So actually on this page, we will actually set up a lead in, lead out. So I'm just going to do a parallel, and it's just going to add some, basically extend the tool path, starting outside more and then going off of the part more. So we're just going to set parallel, and then you can just give it a length. I'm just going to do 1/2 inch for now. And then you have this corners page. Really don't have to worry about this for the most part, but sometimes if you're trying to get like a really sharp corner, maybe you want to use the loop radius. Not really sure why you need the round unless you were just trying to break the edges a little bit, but for the most part, stick with shape or sharp. Sorry, stick to sharp for the external and internal corners. This machine sequence page is used for if you have multiple geometries that you've selected and you want to decide the order in which they get machined. In our case, we only have the one, so we don't have to do anything here. And then on this page, just keep in mind now we have a corner slowdown that you can use for like, pocketing or like inner pockets. But I'm not going to touch this either. We're just going to hit compute. And so there's our toolpath. So as you can see, it's on the wrong side. So what we want to do is reverse that direction. And the way to do that is under default chain start point, just right click on it. And you can hit modify, but I'm just going to hit reverse right here because I know that's all I want to do. So as you can see, the arrows face the other way now. And then if I just recompute, now we get our geometry on the side we want. So if I do a back plot on this now, we can kind of see what it does there. And so I think actually there was one thing I wanted to do on this one real quick. I don't remember. I think there was one thing I was going to do on that one, but that's okay. We can come back to that. So yeah, now we've got that one made. And then two other things I want to do here is I want to add a chamfer mill for the top there. And I want to add, or sorry, not chamfer mill, the rounding, corner rounding. And then the chamfer mill is going to be right here. So let's go ahead and we'll do the chamfer first. So I'm going to do a similar thing that I did in the other one. I'm going to actually just create a line again. So if I go to 3D sketch, line, select that point, hit escape on the keyboard, exit sketch. And that's the line that I want to reference for my my chamfer. Now I think you can still try to use this one below, but typically I would want to use the top of the chamfer. It just makes it a little bit easier for the way it creates the dimensions inside of the feature, and I don't have to change many of those dimensions. It already understands what I'm doing. So now I'm going to blank out the stock too, by the way, just so it's easier to see. And let's go ahead and create our chamfer now. So that's going to be under mill to axis. Select geometry, just click that line. And then we've got this page again, so rapid feed plane, your top. Now we're going to change our top in depth here, so pick top and pick there. And then pick bottom is actually just going to be this other line. And so now we've got everything set up there, and we'll hit next. And we just want the chamfer option, so chamfer mill. And we'll set up our chamfer here. Now I think I had to make it slightly smaller here to be able to not gouge into the wall. So I'm going to do that. And again, this is just what side it's going to machine on. We'll probably have to flip that too. I'm just going to leave it for now. On this page, so as you can see, it's actually already set up the way we want. I've already got my correct depth. And again, you can pick bottom if you want to be sure. There's also different ways that you can come up with the numbers. So like depending on which distance you wanted to use. In our case, we're just going to stick with chamfer depth though. That's all we need. And then one other thing, so there's this cutter position, and it's basically the amount off center of the tool that you want to go. So you can define this distance, and I'm actually going to pull it off just a hair, just because I remember I needed to do that because it wasn't going all the way down. And then that's basically it on this page. So I'll hit next. And again, you have your lead in, lead out, and entry. So on here, I'm going to set this to parallel. So that way we can do a similar thing that we did down here. And I think that's probably enough, is 1/4 inch. Nothing to do here, nothing to do here. nothing to do here. Hit compute. And then I'm just going to flip this here. So again, right click here, hit reverse direction, and recompute. And now we've got it going that way. So now we've got this bottom fillet, we've got the chamfer. Let's also add a corner rounding up here to make this really clean. Technically, you could probably get away with not doing that. You could probably just stick with like using the Z-level finish and just make the step over smaller or the depth of cut smaller. And you get a pretty decent finish, and then you can polish it up afterwards. But adding in this corner rounding will just clean it up really nice. So I'm going to go ahead and show you guys how to do that too. And I think it looks like we have a question actually. Let's see. So, okay, he's talking about machine compensation. There's actually a really good article that we've made for that. So I would visit there first. So basically, if you go to bobcadsupport.com, if you go to the search bar in that website, type in cutter compensation, and it should be the first one that pops up. Just click on that. So basically what that is that we have a knowledge base on our support site that has a bunch of kind of useful information. It was created by our tech team here to kind of help with like general problems that we run into every day, just so you guys can have like a quicker solution. And so that one does a pretty decent job of explaining basically how the machine comp works and system compensation works together. So I would check out there. In your specific case, I'm not exactly sure what you're asking about, but I do know that you do need a non-vertical lead-in for the machine compensation to output in the post. If you don't have if you have a vertical lead-in, it won't post in the post. So definitely have to make sure that you have a non-vertical lead-in. But as far as the errors on your machine, I'm not sure about that. I have to probably get more information about that. So yeah, if you want to contact into the support, we can help with that. But yeah, so hopefully that answers at least some of your questions there. So yeah, let's just continue on now. We'll go ahead and do our corner rounding. So mill to axis, it's going to be under mill to axis. Select geometry. And I think I'm actually in this case, I'm going to use the bottom just because this kind of breaks up at the top here. And so it doesn't really work out very good for a geometry selection. So I'm going to right click on it, and then I'm going to hit select tangency, and it should try to go all the way around. I think, yeah, in this case it didn't go all the way around, so I'm just going to select the extra ones that didn't take. Okay, looks good. So now we'll hit the check mark. So we've selected our geometry. Let's go next. And let's go ahead and set up our top and depth again. So pick top, and then pick bottom. So as you can see, these numbers make sense because we set our machine origin to the 0 of the top, and then we're going down. Yeah, we're going down to the depth. So now we'll just do. Now I don't actually know why the corner rounding is not up here, but it is right here. So I'm going to move it over and delete the other ones. No tabs here. We'll leave all that default. For this one, I just want to make sure I have the same radius as that radius here. So that was, I think it was 16th. Yeah. So we'll do a 16th there. I'll just leave all this other stuff default. Again, we're not going to really cover that in this one here. And then we have our patterns page. So what side we're going on, I'll leave all that default. Depth of cut, don't have to do anything here. Leads, we could add a lead in. Yeah, we could probably add a lead in here if we want to lead into the part. So you have like a circular lead in to kind of blend into the profile. And you can kind of set this, there's multiple different little toggles here that you can set this up. I'm just going to leave it on the default for now. Nothing here, nothing here, nothing here. Hit compute. And that's on the wrong side, so right click, reverse direction, compute all toolpath. Okay, so now you can see that's what we've created. Now notice one thing here. Actually, I forgot this is not on. So we can see it's actually going below our bottom. And that's just because of the way that we selected, because we selected the bottom of our billet here. So what we want to do is go back into the feature. And on the parameters page, so this is one thing I skipped over, this depth, this total depth here. So see how it added a 16th inch. We want to just change this to a 16th inch. So that way we are matching the same depth. And then when I hit compute, now we're up to where we want to be. So if we would have selected, if we had some good geometry to select on the top, we wouldn't have had to worry about that. Just like we saw in the chamfer, we didn't have to worry about that. But in this case, that's why we need to adjust that. And so I think that's basically it here. So let's go ahead and review the different features again real quick. So we'll start off from the top here. We've selected our workpiece, remember in the beginning there. We've created our stock. We've created our machine setup. So it's going to be right here. And remember, it's the Z is in line with the face of our part. And now, then after that, we've created a milling feature, or a facing feature here to face off the top and go down to the zero of the Z0. And then after that, we've created a 3-axis feature. Our geometry selection is just the whole model. And we've created a roughing strategy to rough out most of the material. We've created a Z-level finish strategy to get the walls. We've created a flatlands to machine all the flat areas. And then after that, we've created a line down here to just have a tool just run right across that to get a really smooth, clean finish. So we just have a tool that fits that radius, and we just use a 2-axis to just run it across there in one hit. Then we have a chamfer mill to create the chamfer right there. And then we have our corner rounding to round out the corners at the top there. So in this example, we have a mixture of the 2-axis and 3-axis features here. So let's go ahead and save this. And yeah, I mean, you can definitely save sooner than that. It just, yeah, it depends on like how much work you've done really. Like I do recommend saving decently frequently. It doesn't have to be crazy, but after you've done a decent amount of work, go ahead and save just in case, because you never know what could happen. So let's go ahead and hit simulate now. So there's a little button I clicked there. You can also right click on milling job and hit simulate as well. Now we get this orientation initially just because of the way that the part was designed in the software. It was kind of just designed in like a skew from the actual coordinate system. So really all we have to do is just move it to the way we want to see it at. There's not much we can do about that other than to reposition the actual model initially to have it line up, but it's really not that big of a deal. You can just rotate it to where you want to see it here. So by rotating in the simulation, you hold left click, and that will rotate the part. Alternatively, you can try to use these views up here, but I'm just going to leave it here. A couple of things in here. So you've got different, so you've got NC mode, time mode, and length mode. I think by default it's going to be set to NC mode, which is fine, but the NC mode, it basically just moves the tool from point to point. And so, if we got this long move here, it's just going to go directly across, like instantly. So I like to use either time mode or length mode to have that smoothing out, and just to have, it's just better to see the simulation. It's easier to see what's actually happening. So either do length mode or time mode. And then you have the speed right here, so you can adjust the speed of the simulation. So that's another one I use. And then if we go over here, you have visibility, so you can turn off and on a bunch of things like the workpiece, the stock, and everything like that. But one thing I like to do over here in the toolpath rendering is I'll keep it on segment. I think by default it's set to all operations, or yeah, I think it's set to that one. I can't remember. It's set to something else where it shows all of the toolpath, but I like to use segment just so I'm seeing just ahead of me, and I don't have to see a bunch of stuff in the way, a bunch of toolpath in the way. So now I'm gonna go. Let's just go ahead and run this. Oh, and my tool is blanked out. Might be helpful to see that. And so, yeah, we can just run through here, just see what it's doing. I'll just speed this up a bit. Oops, too fast. No, that's too fast. Hang on. Also, this should be set to segment. There we go. Okay. So segment. So now we only see the one. So restart. Let's do just a little bit slower. Okay, there we go. And we can just see kind of what it's going to do here. So, and I use the move list over here is really cool too. It shows which one's currently being used, and then you can actually, if you pause it, let's say I click on chamfer mill, it's going to load all the toolpath all the way up to this point at the start of this operation. So it's really good to use if you're just trying to see like what one of the operations do, rather than having to run through it a bunch of times. And then yeah, you can kind of just see what it's doing here. So we'll let that run through here. So right now we're doing the advanced rough, and then yeah, as you can see, it's just machining it by levels here. And it's just going to do this all the way down. So I'm just going to go right to the Z level finish. And so again, this is the Z level finish, and it's just going to machine the finish all the way down the walls there. As you can see. And you can adjust the depth of cut step over to whatever you need to for your specific case. I don't really know the exact numbers you would want to use for all this stuff. It really that depends on a bunch of different factors. But yeah, I just wanted a really clean finish on this, so that's why I did that. Actually, let's go back to the flatlands here now. So now we have our flatlands, and you could probably use a bigger tool as well, and then try to get in the corners after that. But I just did this all in one feature or one operation, just so you can kind of understand how this works first. But as you can see, it's just cleaning up all our flat areas now. And that remaining material is just that 15 thou that we set up. And again, because on the advanced rough, since we set it to machine flatlands, it added additional pass on these levels to get down to that 15 thou. So yeah, so then it just goes through there and does all the floors. So we'll just go to the next operation now. And now we've got that profile finish pass there. So we're just literally just running straight across part there to finish it up. And as you can see, there's the little cuss from that Z-level finish that it left because this is the flatter area. So as we go across, we get a nice, clean, smooth finish there. Now we're doing the chamfer to clean up the chamfer. And then we're using the corner rounding to clean up the fillet at the top. And so, yeah, so that's kind of how you can go through here to kind of get an idea of what it's going to look like. And yeah, that's basically it for the simulation. So when we're happy with everything there, we're just going to exit out here. And I was going to show the other side, but we kind of ran out of time here. But you can basically what I was going to do is create a second machine setup. So we just did most of the work from the top there, right? So what you would want to do now is, flip the part over and get the other side. I actually have seen people create putter heads before, and typically they actually just use they just do it manually at the top. They just face off the top manually. But if you wanted to try to do it with CNC, we would create a second machine setup. So if you right click on milling job, add setup, and what it does is it adds a second machine setup right here. And from here, you'll want to redefine your new machine origin location. So you would right click on that, hit edit, and then you would set up your second machine setup as you did the first time, just for the second one on the other side. And then you would just go through the same process and just do the same thing on this side. The only kind of maybe challenge to this one would be that we have that 4-degree angle, right? So I can't just, you could either try to position, make some soft jaws or something to position it to be flat. Or if that's too difficult, you can just take like a planer toolpath. And the planers, that's the one I didn't show, but the planer's good at just running across the top there. So those are kind of some of the options you could do maybe if you wanted to do a second machine setup. But I think, showing the first machine setup, that's going to show you most of what I was wanting to cover in this webinar. So hopefully that gives you guys a good idea of kind of the process and workflow. Obviously, at the end of that, you would also post the code. We might need to post it to send it to the machine. So there's just a button right here. You can also just right-click post. Also, you have the the setup sheets. You want to generate a setup sheet, so you have those type of options. But yeah, that's basically all I wanted to cover today. Hopefully you guys learned a little something there. I'm one of the techs here, so if you ever need any help or you run into anything, just let me know. My name is Paul, and I can assist you guys there. Did anyone have any questions today? Maybe, maybe not. All right. Oh, maybe. No. Okay. No questions. Great job. Thank you. Okay. Appreciate it. Awesome. All righty. Well, perfect. I'm glad I was able to show this to you today. Again, if you need any more help, just give us a call. So I hope you guys have a good rest of your day there. All right. Bye.